In this video, we're going to talk about bypass capacitors, the types we use, why you use them, where you place them. So let's take a quick look. I have power coming in right here, and I have my circuitry down here. Now, my job as an engineer, I'm designing this board. I don't know where power is going to come from outside from my board. Right? I have my little circuit board with my connector here. I don't know if the power is coming from 3 inches away or 30 feet away. So keep in mind, if my power is coming from 30 feet away, that's a long way, there's going to be a lot of resistance in that wire over that distance. Also, there'll be a lot of inductance. So I can have voltage drops when there's power surges, and I can have a lot of problems with that. So I have to think about that. So what I want to do then is place capacitors right where my power comes in. So let's come here and place a capacitor. So I went to my miscellaneous devices and my components. I click on capacitor. If you look at the capacitor here, here's some information on it. Even the footprint. The footprint is what it's going to physically look like on the printed circuit board. Now remember, my capacitor symbol looks the same. It could be a little tiny capacitor this big. It could be a giant capacitor, right? The symbol's the same. The footprint is what it really looks like. So I'm going to double click my capacitor. There it is. And it says 100 picofarads. I actually want to use 100 nanofarads. So before I place it, because this is going to save me time, I'll show you if I don't do that. If I just come up here and place this, so now I have those two caps placed up there, and I have to come back and edit them. They have the wrong value. But if I hit tab and I come down here to the value and say really what I want is 100 nanofarads. Now look, my cap says 100 nanofarads, and I'll place 100 nanofarads. So I'm going to place one up here and another one down here. We'll talk about why here in just a second. First, I want to edit these values that I placed that were wrong. That one now says 100 nanofarads. Remember, that's one way to do it. I can also come up here and highlight this, select the properties. More than one way to do the same thing. I'll wire these guys so they're connected to ground. Alright, and then I'll place a ground on these guys. Alright, so now I have 100 nanofarads. I have my red squiggle line, it's warning me. I know how to fix that. I go to annotation, annotate schematics quietly, update those 4 capacitors, and I'll save it. So now I have 100 nanofarads where the power comes in, and I put 100 nanofarads right next to this op amp. Let's talk a little bit about why and what other capacitors we might need. Now, capacitors have their own set of properties. I put 100 nanofarad here, which is going to be a small ceramic capacitor. When they say ceramic capacitor, it is exactly what it is. It's a little piece of ceramic, a little disc, kind of like this little can. They'll take this piece made out of ceramic and they'll plate metal on this side, plate metal on this side. That becomes the dielectric, and they put 2 leads on it. So now I have a little capacitor. The good thing about ceramic capacitors is they're very fast. They can react very quickly. And they have what's called a low ESR. And ESR means the equivalent series resistance. Capacitors have some resistance, right? They also have some inductance. So these have very little series resistance. That helps them react quickly. So if the power fluctuates up here, this guy can react quickly to try to filter that out and keep it steady. The downside is it's only 100 nanofarads. That's not a lot of charge. So if I have a very quick spike, very quick like that, this guy can react. If it's a slow sag, this guy's going to run out of charge and he's not going to be able to help us. So in that case, we're going to go back to our components, and here's a capacitor that says POL1. That's a polarized capacitor. All right, when I put this guy in, it's going to be a polarized. And what does polarized mean? Well, it's an electrolytic capacitor. Let me double click this here. you'll see the symbol slightly different. I'm going to hit tab again to save myself some work, and I'm going to put 100 microfarad. You see where I changed that value? Now I have 100 microfarad. So let's rotate this guy, and he can go right here. 100 microfarads. And I need another one over here, but wait a minute, that's minus 12 volts. I can't do that. I need to do this. And why would I do that? Let's look at that very quickly. The ground is more positive than the minus 12. So I need to put the positive side of this cap to ground and this guy to the minus 12. Now these caps, the electrolytics, are polarized. They work fine as long as this side is more positive than this side. If you don't do that, the problem you run into, it almost looks like a diode. If you put it in backwards, the current's going to flow right through it like a diode, and it's going to get hot. Then the little can, because they look like little cans, they swell up like that and they burst and let all the liquid out, and it's not a good thing. So remember, you always want to make sure you have your cap, your polarized caps, in correctly. Now look at this. I have C1 and C2. These are not labeled. If I come up here and say annotate quietly, we can label those. But if I start looking at the order, I have 1, 5, 6, 2. Maybe if I'm a little more motivated and I worry about everything being in order, right? Maybe I got problems with trying to keep everything looking really nice, and I like it to look nice because this is basically my artwork that I'm handing to another engineer at some point. I'm going to go back to my tools and go to the annotation and say reset all the designators. There's 13 designators. What do I want to do? Do I want to reset them? Yes. Now look, they're all question marks. Now I'm going to tell it annotate all schematics quietly. Right, here we go. Boom. Change them all. Now I got them in order, right? I can see them in order. This is a lot better. Well, I have 1, 2, 3, 4 up here. I'm happier with this. So let's save that. And let's look and pay attention. Why did I put 100 microfarad in parallel with 100 nanofarads? Then I get 100.1 microfarads. Well, that's because I told you this cap is very fast, but he doesn't hold much charge. This cap holds a lot of charge, but he's not real fast. When I put those two together, I get the benefit of both. If I have a slow sag, this big 100 microfarads can take care of that and keep the power supply more steady. If I have a very quick little spike, this guy can't react fast enough, but this guy can. When I put them together, voila, I get this great benefit of both. But then I have another 100 nanofarads over here. Why would I do that? Well, the reason I do that is, and it's good engineering practice, and you should always do this, you don't have total control over how far away this jack is from this part, because on a big design, this power jack's up here, and I could have 25 active chips all over the board. Well, by the time this power lead goes to all those chips all over the board, I start adding inductance and resistance. And what happens again? Inductance tries to fight a change in current, so when I get a current change here, the voltage will drop. The resistance, same thing. I run current through it, the voltage drops. How do I fight it? I put a 100 nanofarad cap right next to the active part. And you'll see when we go to the printed circuit board that these caps are going to be right next to this connector, and these caps are always going to be right next to the active part. I'm not going to take it and stick it way over here in the board. I want it to be right next to it. So this is a very important function that some people will leave out on their projects, and when they do, sometimes it causes them problems because their power supplies get noisy. You'll see on your LM386, on your Design 1 projects, the little audio amplifier, sometimes that audio amplifier will oscillate if it doesn't have this bypass cap right next to it. Sometimes regular op amps have problems too. Noise on the power supply comes through on the signal. You want to get rid of that. That's not our function to add noise. It's our function to keep it clean. So make sure you add these caps. That's the whole reason I made this short video for bypass caps, so that you'll understand why we put bypass caps here and what their functions are. Remember, on a polarized cap, you have to keep the polarity right. Ground is more positive than -12, so that's why this one's upside down. Okay, thanks.